Okay, a lot going on with this one. We want to identify extrema. We want to find increasing, decreasing intervals. We want to find concavity. We want to sketch a possible graph. Oh, by the way, we're given the derivative. Okay, so what does that mean? Well, if I know that 4x cubed minus 12x squared is my derivative, I can start off by just setting that guy equal to 0. So 4x cubed minus 12x squared equals 0. This will tell me where my function increases and decreases. And to do that, I'm just going to factor out a 4x squared from everything here and set each piece equal to 0. And I'm going to have x equals 0 and x equals 3. So when I make my sign chart, this is for increasing and decreasing behavior. Okay, I'm going to have 0 and 3. And what I'm going to do is I'm just going to look here at 4x squared, and I'm going to look at x minus 3. And I'm going to pick a number, -2, and I'm going to put it in. I'm going to pick a number 1 and put it in. I'm going to pick a number 5 and put it in. So I'm going to put -2 in for all these things. Well, that's going to be positive the whole time because a negative number squared is positive, and a positive times a positive is positive. So again, I don't need to know what the exact answers are, but I'm positive here. When I put 1 in, 4 times 1. I want to put 5 in, 4 times 25. Now for the negative side, for the x minus 3 part, put -2 in and I get a negative number. Okay, -2 minus 3. When I put 1 in, I still get a negative number. And then when I put 5 in, I get a positive number. So what do I get from this? Here's what I'm going to learn. I'm going to learn that I have decreasing, my function is decreasing. Something happens at 0, it decreases again, and then it increases at 3. Now I can't draw my graph yet because I need concavity. So what are my increasing intervals? My intervals increase. I increase from 3 to infinity, and I decrease from negative infinity to 0 and from 0 to 3. That's all I know. Now I don't know how it's decreasing. It could be doing a bunch of wacky stuff. Now, second derivative. What's that going to be? Take the derivative of the first derivative. So it's going to be 12x squared minus 24x. And set that guy equal to 0. So when I do this, I can factor out a 12x. Whoops, that should be 1x. So that should be x minus 2. Set each piece equal to 0, and you get x equals 0 and x equals 2. And make one more sign chart here. And we'll use 0 and 2 as our values. And so we're going to check 12x, and we're going to check x minus 2. Let me move that over a little bit. We're going to check these two values, and again, we're going to check it on numbers in these ranges. You can pick whatever number you want. You just need to pick numbers that are inside these 3 different areas that we've created on our number line. So when I put -2 in, I get a negative on the top. When I put 1 in, I get a positive, and this is in 12x. And when I put 4 in, I get positive. And how do I know that? Because -2 times 12 is a negative number. 1 times 12 is a positive number, and 4 times 12 is a positive number. Now check x minus 2. When I put -2 in, I get a negative number. Okay, -2 minus 2 is negative. 1 minus 2 is still negative. And 4 minus 2 is now positive. So what does this mean for us? Well, it means that I'm positive here, so that means I'm concave up. I'm negative here, which means I'm concave down. And I'm positive here, which means I'm concave up. Now, let's go back up here and check this guy out. I'm negative, so I'm decreasing. I'm negative again, so I'm decreasing. And then I'm positive, so I'm increasing. So we're going to add all this together, and we're going to graph it over here on my graph. And I know that I got crazy stuff happening at 1, I got stuff happening at 3, and I've got stuff happening at 2. And I don't know exactly what this graph is going to look like, but I can put a pretty good shape on it. maybe not an exact shape that we would want it to have, but we can get a good narrowed down feel. So I'm concave up but decreasing to 0. Okay, well, what value am I at when I put 0 into my equation up here? So 4 times 0 minus 12 times 0. Okay, so I'm concave up and decreasing to 0. And I shouldn't have done that because that's my derivative, not my original. Then I'm concave down and decreasing to 2. So notice I'm concave up. So now I'm concave down and decreasing to 2. Okay, and at 2 then, at 2 I become concave up, but now I'm increasing. So at 2 I'm going to be concave up and increasing. Let's see if I can get a smooth transition up. So here's a possible graph. Concave, something like that. Which my graph didn't quite resemble that shape, but this guy's a better shape than my original. It's hard to tell the concavity in there. So use this guy as your point of reference. I wish I could line him up. I don't know how to grab that whole shape. Let me see if I can grab that whole shape right here. Oh, no, I'm not going to do that. Okay. So anyway, there you go. That is tying all this together at one full swoop, and it's really, really cool to do and to see how all those things work. So anyway, that's why these derivatives are neat. First and second derivative tests allow you to figure out and determine exactly how your graph may or may not, a good rough idea of what your graph might look like. Just set each piece equal to 0, set each derivative equal to 0, create a sign chart, and if you're not super comfortable with sign charts, just kind of watch how I did this, like what I did. You'll understand later. You just need to work through a few of these problems, just going, okay, he did this. And once you've got it, it's super handy. You've seen them before. This hopefully is just a quick memory reminder for you.